So welcome to our today's lesson. We shall be looking at ion formation, the valency, radicals, and the chemical formulae. The objectives of the lesson is number 1, state the valency, describe how atoms form ion, the chemical formulae, and the radicals. To define, valency can be defined as the combining power of an element. In other words, the number of electrons an atom loses or gains to form an ion. In our previous video, we looked at how ions are formed. We looked at also the energy levels of different atoms. We also mentioned that an octet is a situation whereby an atom has 8 electrons in the outermost energy level, while a duplet is a state whereby an atom has 2 electrons in the outermost energy level. The only elements that have octet and duplet are the elements belonging to group 8 of the periodic table. Ideally, these are the atoms that have a duplet state. So in our today's lesson, we will be looking at how other atoms attain a duplet state. And why will we be looking at that? It is because for atoms to react, they have to have attained a duplet or an octet state. In other words, for a reaction to take place, it does so when other atoms obtain a duplet or an octet state. How then does that happen? That one happens when we have what is called the ion formation. So when we speak about oxygen, for example, oxygen is atomic number 8. That means that it has 8 protons in the 8 protons and 8 electrons. So in this, the electrons are usually arranged in the outermost energy level as follows. We have oxygen, then we have the first energy level and the second energy level. Like you can see, the first energy level will have a maximum of 2 electrons, and then the second energy level has 6 electrons. This means that this atom can as well gain 2 more electrons to have an octet state. So the number of electrons oxygen requires to form an octet state is what we call, or what to refer to as, the valency. Remember, when we speak about the valency, it can easily be got from the electron configuration. Let's look at this example. The electron configuration of oxygen is 2, 6. So this means that the outermost energy level has a total of 6 electrons, while the first energy level has a total of 2 electrons, giving us 2:6. Therefore, for oxygen to form an ion, it is easier for oxygen to gain 2 more electrons than to lose the 6 electrons. look at this in a drawing. We have oxygen at the middle, and then we have the first energy level that has the first electron and the second electron. When we get to the second energy level, it will have the 6 electrons. So this is oxygen atom. For this oxygen atom to form an ion, its valency is 2 electrons. And what does that mean? This 2 is the number of electrons it requires to attain an octet state. For that case, we can say that the valency of oxygen is equal to 2. Let us look at another example. Example of lithium. Lithium has an atomic number of 3. If we write the electron configuration of lithium, it is 2:1. This means that the first energy level of lithium has 2 electrons, while the second energy level of lithium has only 1 electron. So, for lithium to react, it has to lose the 1 electron so that it has an duplet state, and that is 2 electrons, because it is easier for lithium to lose 1 electron than to gain 7 electrons to form an octet state. Let's look at another example, magnesium. Magnesium is atomic number 12. That is for magnesium. So if you are to write the electron configuration of magnesium, it is 2, 8, 2. If you add this, you get 12. So it is easier for magnesium to lose these 2 electrons than to gain 6 more electrons to form an octet state. Therefore, the valency of magnesium is 2. If its valency is 2, then the ion of magnesium will have an electron configuration of 2:8. Ideally, the number 2 here is the number of electrons that magnesium requires to form an ion. Let's look at another example. An example of chlorine. Chlorine, on the other hand, is atomic number 17. So if you were to write the electron configuration of chlorine, then it would be 2, 8, 7. If you add 2 plus 8 plus 7, you get 17. So for chlorine to form its ion, then it requires to only gain 1 electron to have an octet state of 2:8. Why will chlorine gain 1 electron? Chlorine gains 1 electron because it is easier for it to gain 1 electron than to lose a total of 7 electrons. Therefore, atoms react by either losing or gaining an electron. What is coming out very clear here is that Non-metals, and an example of a non-metal is oxygen and chlorine in our example, will react by gaining electrons, while metals themselves, and the examples that we have is lithium here and magnesium, will react by losing of electrons. Let us look at our next slide. Ion formation for metals now. Sodium, the atomic structure of sodium is as follows. Sodium with the first energy level having 2 electrons. We have the second energy level having 8 electrons. And then the last energy level, that is the third energy level, having only 1 electron. Where are we getting this from? We are getting this one from sodium being a metal with an atomic number of 11. This means that its electron configuration is 2, 8, 1. If you add 2 plus 8 plus 1, you get 11. And the same, if you add this first electron here, plus this electron, plus this one, this one, this one, this one, this one, that one, that one, that one, plus this other one, you get 11. So that means that sodium has a maximum of 11 electrons and only 1 electron in the outermost energy level. Therefore, for sodium to form an ion, then it does so by losing the electron in the outermost energy level. How does that happen? Let me show you. Sodium will form an ion by lose 1 electron. After losing 1 electron, it now forms an ion with this electron configuration. First energy level, first electron, then we have the second energy level like that, with how many electrons? With a total of 8 electrons. And then we will have this one in bracket like that, so that now we can say that it has become positively charged, and it is positive 1. But then we can ignore the 1 because the positive itself means that it has a charge of positive 1. I hope you understand what I mean. Let's look at another example, and that is the example of magnesium. Magnesium has an atomic number of 12. If it is 12, that means that magnesium has an electron configuration of 2, 8, 2. If we draw the electron configuration, the atomic structure of magnesium, magnesium will look like this. We will have magnesium, then the first energy level with 2 electrons, the second energy level with 8 electrons, and then the last energy level with only one electron, this magnesium atom. It will form an ion by losing 2 of its electron in the outermost energy level. Why? Because its valency is 2. That means that it is easy for magnesium to lose the 2 electrons than to gain 6 more electrons to form an octet state. So when it is losing electrons, we will have magnesium ion. And how will we draw magnesium ion? We'll have magnesium ion now having the first energy level with 2 electrons, and then the second energy level with how many electrons? With 8 electrons, like that. And then from this we have brackets and closing it like this. Then we can have positive 2. The positive 2 in this case represents the charge of magnesium. Ideally, we write it as 2 positive. So it is 2 positive. And basically that is how magnesium forms an ion. Let's look at how aluminium will form its ion. You can pause the video for some time and try to see whether you can be able to write the atomic structure and the ionic structure of aluminium. Are you there? I hope you just did that. So let's try to draw the atomic structure and the ionic structure of aluminium. Aluminium, on the other end, has an electron configuration of 2, 8 to 3. This is from the fact that it is atomic number 13. So 2 plus 8 plus 3 gives us 13. Its atomic structure will look like this. We will have the first energy level with 2 electrons, and then we will have the second energy level with 8 electrons. First, 2, 3, 4, 5, 6, 7, and 8. And then we will have the last energy level, that is the third energy level, like this, with just 3 electrons. So that is the aluminium atom. It will form an ion by losing 3 of its electrons in the outermost energy level. So that now it forms an aluminium ion. How do we draw aluminium ion? The first energy level with 2 electrons, and then the second energy level with 8 electrons, like that, and then we will encross it like this and write 3 plus on top. The 3 plus represents the valency. That is to mean that for aluminium to form an ion, then it does so by losing 3 electrons. So its electron configuration for the ion for the atom will be 2, 8 is to 3. But if you look at the electron configuration of its ion, then it is 2. It is 2 is to 8. What we can conclude now from the observations is that all metals form ion by just losing electrons. Sodium will form an ion by losing 1 electron. Magnesium will form an ion by losing 2 electrons. And aluminium will form an ion by losing 3 electrons. Note that this 1 electron is the electron in the outermost energy level. These 2 electrons are the ones that are the outermost energy level, and these electrons are the electrons at the outermost energy level of aluminium, magnesium, and sodium, respectively. Another observation that we make is that after they form positively charged, ions or metals. After losing the electrons, they form positively charged ions. And another key observation is that the size of the ion is always smaller than the size of the atom itself. Why? Because after losing 1 electron, there is a loss of 1 full energy level. Let's now look at ion formation for nonmetals. And in our case, we will use the 3 examples that we have. The first one, oxygen, chlorine, and fluorine. In these 3, remember that the atomic number of oxygen is 8, the atomic number of chlorine is 17, and the atomic number of fluorine is 9. We begin with oxygen. The atomic structure of oxygen looks like this. We have oxygen, the first energy level, and the second energy level, like that, whereby the first energy level has 2 electrons and the second energy level has 6 electrons, like that. This one now is sodium atom with electron configuration of 2 to 6. So sodium will form an ion by gaining 2 electrons. When it gains 2 electrons, it attains an octet state of 2:8 because it has now 8 electrons in the outermost energy level. So its ion will look like this. We will have oxygen followed by the first energy level and the second energy level. The electrons will be distributed as follows: 2 electrons in the first energy level, the first one, second, 3, 4, 5, 6, and then it will now gain 2 more electrons, and then now that will be its ion, and we will have the charge as 2 negative. The electron configuration of the oxygen ion will now be 2:8. You know that we have these brackets to show that it is now an ion having gained 2 electrons to attain an octet state. We look at another example, chlorine. Chlorine has an electron configuration of 2, 8, 7. So if we have chlorine atom here, let me just extend it here. If we have chlorine atom here, it will have the first energy level with only 2 electrons. the second energy level with 8 electrons. And then the third energy level with 7 electrons. So we will have 1, 2, 3, 4, 5, 6, 7 electrons. Now, it will form an ion by gaining 1 electron to attain an octet state. So that now it looks like this. Chlorine, we have the first energy level. So the first 2 electrons in the first energy level, followed by 8 electrons in the outer energy level. And remember, these 8 electrons are these electrons. And then now the 7 electrons, we will have them in this very last energy level. The 7 of them, 1, 2, 3, 4, 5, 6, 7. Then now it will gain 1 more electron here, so that it has a total of 8 electrons in the outermost energy level. And then it will have now an octet state with a negative charge. And then the electron configuration now of the chlorine atom will be 2, 8, 7, while that of the ion now will be 2, 8, 8. You can see that there is a difference of 1 electron, and that is the electron that is gained in ion formation. Let us look at the last example, which I want you to try. You can pause the video for some time, try to work this one out. Welcome back. Let us now look at how fluorine forms its ion. And fluorine has an atomic number of 9. That means that its electron configuration is 2:7. It has 2 electrons in the first energy level and 7 electrons in the outer energy level. So if we begin with it, having fluorine, the first energy level and the second energy level. So we will have the first 2 electrons in the first energy level, and then the other energy level will have 1, 2, 3, 4, 5, 6, and then we have 7 electrons with the electron configuration of 2:7. So for fluorine to attain the octet state, it needs to get 1 more electron, and that more electron is gained. So we will have gain 1 electron to form fluorine still, but then it is now an ion. We have the first energy level and the second energy level like that, with the first energy level having the 2 electrons, and these are the 2 electrons. And then we have the second energy level having the 7 electrons, and these are the 7 electrons that we're speaking about. distributing this way. 1, 2, 3, 4, 5, 6, 7. And now because it forms an ion by gaining one electron, we will put that one electron there and then put a bracket like that and say that it gained one electron. When it gains one electron, it has an excess of negative charge, and for that case we have a negative on top there to show that this one is an ion that has an electron configuration of 2:8. In our next slide, we now look at how the chemical formulas are formed. And to begin, what is a chemical formula? A chemical formula, we can say that it is a representation that shows how elements combine to form compounds. These compounds are usually represented by chemical formula. And the chemical formula now shows the constituent elements forming the compound and the proportion in which these elements combine. And in this example, we shall use the example of sodium chloride and magnesium chloride. In writing chemical formula, we need first to know the chemical symbol of an element that is forming the compound and also its valency. Remember that the valency of sodium is 1, while the valency of chlorine is 1 as well. So we write sodium, that is its chemical formula, and then chlorine there, and then on top of them, the superscript, we write their valencies. After we've done that, we interchange these valencies so that now the valency that was in sodium is taken as a subscript for chlorine, and then the valency which was the superscript for chlorine is taken to sodium. The resulting will be now sodium with this one now comes here. And then we have chlorine, and then this one here comes here, giving us now the formula of sodium chloride as sodium chloride. Note that we begin with the atom that is losing the electrons, followed by the one that is gaining the electrons. For that case, sodium being the one that loses one electron is the first one, followed by chlorine. We can simplify these ones so that we are left with the simplest form as this one, sodium chloride. We look at the next example of magnesium chloride. The chemical symbol for magnesium is Mg, while that one of chlorine is Cl. The valency of magnesium is 2, while the valency of chlorine is 1. The same way we just did to the valencies of sodium and chlorine, we interchange these valencies like this, so that now we have magnesium, and then this one we now write it here, followed by chlorine, and then this 2 we take it down here. Simplifying this will require us to eliminate this one, so that now we have a formula of magnesium chloride being written as this. Simple. Next now, we look at the radicals. Radicals are defined or is defined as a group of atoms with a net charge and an ability to react as an unit. So while we said that when elements combine, they form a compound, a radical on the other end is now a group of an atom, but unlike a compound, they carry a charge. We have radicals that have a valency of 1, we have others that have valencies of 2, and we have those that have valency of 3. Examples for valencies with a for radicals with a valency of 1 is ammonium, hydroxide, nitrate, hydrogen carbonate, and finally hydrogen sulfate. Those that have a valency of 2 are carbonates, we have sulfates, and the sulfites. And then for trivalent, we have the phosphate. So we might need now to ask ourselves, how do these radicals react? And in our next slide, we look at how sodium sulfate is written. Remember we said that the radicals react as a unit. What does that mean? So to write the formula of sodium sulfate, we will begin with sodium. Let me just rub this on to use a color that is more visible. We will use sodium. The valency of sodium, so that's sodium. The valency of sodium is 1. And then from our slide we just said that the valency of sulfate is 2. So we write sulfate here, and then its valency is 2 negative. So what do? We interchange these valencies like this, so that now we will have sodium with the valency of, we carry this valency now, it comes here, and then we have sulfate, the valency 1 comes there, but then there is no need of having 1, so we can just leave it at that as that formula, because 1 multiplied by any other number just gives you a 1. And that one now gives us this as the formula of sodium sulfate. We look at the next example, where now we have magnesium carbonate. We begin by writing the formula of the atom that will lose an electron, and that is magnesium, then followed by carbonate. Remember, this is the formula of carbonate radical. So we will take it here and write carbonate with a net charge of 2 negative. And remember that the valency of magnesium is also 2. So, like we have done with the other examples as well, we interchange the valencies, so that now we will have magnesium. We carry this to this place, and then we will have carbonate following like that, and then there is this valency 2 here, we bring it here. Note that when we carry the valency of a radical, we don't carry it with the charge, we just write it without the charge. So this one now becomes the formula of, we have this one as carbonate, so we will carry this charge, this +2, and bring it here. But then you know that we can cancel out. This 2 and this 2 can cancel out. So we simplify the formula of magnesium carbonate as follows. As now magnesium CO3, after now cancelling out the twos at the subscript of magnesium and at the subscript of the carbonate. So let us look at the last example, and that is the example of magnesium nitrate. When we come to magnesium nitrate, it is nothing different from the examples that we've just looked into. We write magnesium, then followed by the radical of nitrate as this formula. We'll have it this way, NO3, and then we have a valency of 1, and the valency of magnesium is 2. So we interchange the valencies as usual, so that 2 comes here and that 1 comes here. Now note that when this 2 comes down here, it will come to multiply. It will be multiplied by all the nitrates that the nitrate that we have. Or in simple terms, we will have magnesium. We will have magnesium. We carry this valency and we write it here, followed by nitrate. And then now nitrate has a 3 here, and we want now to bring this 2 down here. If we just write it here, it will confuse us because it will be like 32. So to solve that dilemma, we put a bracket, and then we will have our 2 down here like this. But then having 1 here is very insignificant. Therefore, the formula of magnesium nitrate can be easily be written as Mg into bracket NO3, and then we will have a 2 there. Ideally, that is the formula of magnesium nitrate. Thank you for watching. Kindly subscribe to the channel and as well share with your friends so that together we build an ocean of chemistry. Thank you.